Okay, so today we're going to do inverse functions, and a lot of people don't like this topic, but it's not that bad. So, an inverse function, it pretty much, what's the right way to say it? Okay, so an inverse function, it undoes the original function, or it reverses it. Right? Okay, so how do we find it? It's pretty simple. You switch, step one, you switch x and y, and then two, you solve for y. So, two easy steps. So let's do the first step. So we have y equals x plus 2 to the third plus 3. So this is a y, we're going to make it x. X equals y plus 2 to the third plus 3. Let's graph the original one too, just real quick. So we know that this is going to be, oh, they already graphed it for us, right? This is the original right here. Right, we know it's a cubic. It had a shift 2 to the left, a shift 3 up. So that's how we got that graph. Okay, so we switched them. So now we need to try and find, we need to solve for x. So what we want to do is we want to subtract 3 from both sides. Minus 3, because we're trying to solve for y, right? So we want to get rid of the stuff around it. So we have x minus 3 equals y plus 2 cubed. And then we want to take the cube root. So take the cube root of everything. So we're left with the cube root of x minus 3 equals y plus 2. And then we subtract 2 from both sides. So we get y equals cube root x minus 3 minus 2. So this is our inverse function. Let's take a look at our graph here. So this is our original, right? We have negative 2, 3. We have negative 1, 4. We have negative 3, 2. And we have negative 4, and this looks like negative 5. So the cool thing about an inverse function is you actually just flip the points, right? So what was x now becomes y. And
in this case, would x be 3 and then...
Yeah.
Okay.
Yeah, nice. So just switch the numbers. 3, 4, negative 1, 2, negative 3, negative 5, negative 4. So I just want to be clear. Right, let's add a note here. F negative 1x means inverse of f of x. It does not mean 1 over f of x. Right? Because sometimes we're used to, right? Because like we see like x to the negative 1 equals 1 over x. This is a little different, so don't get confused with that notation. Okay, so we have our other function. Let's do it in, I don't know, green, just to show. So we can graph these points. We have 3, negative 2, 4, negative 1, 2, negative 3, negative 5, negative 4. And we can connect these. It's a little tricky. Okay, so the way that you'll want to think about this is these graphs. Here, I'll label the points, right? We have, let's do that, the center point of a cubic, right? Negative 2. And this is 3, negative 2. So when you have an inverse function, you are actually reflecting it about the line y equals x.
So in a sense, it's kind of like diagonal?
Like if I were to take this graph and fold it on that line, the graphs would match. See how it's like the same thing but flipped over? Yep. So that is what you, when you think of a graph of an inverse function, that's what you get. And if you actually thought about it, if you were to graph this from scratch, a cube root would look like this, and then we just shifted it. We shifted it 3 to the right and 2 down. So you can go back to your original like parent functions and try and graph them. All right, let's take a look at another example. This is just something where you need lots of examples. Or actually, let me leave it right here, right? Inverse functions reflect about the line y equals x. Mirror if folded over line. Hopefully that makes sense. All right, let's take a look at the next example. So our first step, we switch our x's and our y. Actually, let's look at this graph first. Okay, so we have this. So we could put it on a graphing calculator if we want, or we could just remember the square root of x, right? Let's do square root of x. So we have 0, 0, we have 1, 1, we have 4, 2, right? So we have this sort of curve right here. If we were to graph this, we would shift it. Well, we could shift it and then stretch it, or we could stretch it and then shift it. So let's do the shift first. So if we have negative 2 of x would be, you flip it, right? So whatever the point would be, right? So that's our new one. And then we're going to shift it. 1, 2. So this is just practice of graphs, right? Like our translations and everything. Now we're going to add our horizontal and vertical shift. So we move 3 to the right and down 2. So 1, 2, 3, down 2. 1, 2, 3, down 2. And then 1, 2, 3, down. Points off the graph, right? So we have our new graph right here. So this is what our graph would look like, right? And we did that without a calculator. We took the original parent function, then we added the stretch, and then we added the shift, yeah? Okay, so this is what it looks like before. So this gives us an idea of what it's going to look like once you flip it over. But let's just do that algebraically right now. So we have y equals negative 2, x minus 3 minus 2, square root of x minus 3 minus 2. So then we're going to change it. So this becomes x equals negative 2 square root of y minus 3 minus 2. Okay, so what we'll want to do first is add 2 to both sides. So we get x plus 2 equals negative 2 y minus 3. Then we're going to divide both sides by negative 2. And we get x plus 2 divided by negative 2 equals root x minus 3. Then we're going to square both sides. So we get x plus 2 minus negative 2 squared equals y minus 3. And then we finally add 3 to both sides. Right, so it's pretty gross, but it's something that you can do algebraically. Like, you have it within you. So this is the equation. I'm going to clean it up a little bit over here. So we have f prime of x equals negative 1/2 x plus 2 squared plus 3. Alright, so I just replaced the y with the inverse function y, and then I pulled out this negative 2 to be in front of the x plus 2 squared, just to make it visually easier to see. Okay, so we can graph this too, right? So let's start with, we'll do A, B, C. A is x squared. So if we had x squared, we'd have our graph that looks like this. That would be a parabola, right? This is A. And now we want to do our stretch. Okay, since it's inside the square root, we're just gonna stretch it out a bit. Okay, so it's a horizontal stretch. So these points would go out double wide. This is our horizontal stretch. Wait. This is B. B equals negative 1/2 x squared. Right, so this is a horizontal. And then we're going to translate it. Negative 1/2 x plus 2 squared plus 3. So we shift 2 and then up 3. So over 2, up 3, over 2, up 3. This point, over 2, up 3. This point, over 2, up 3. So we're sort of beyond it. Okay. Super ugly, but we're just like reminding you how to do shifts and translations. But we'll also do it on the calculator. Okay, so this is the original graph. The one tricky thing is that if you see, like, it's not exactly mirrored. So we actually have to cut off a portion of it so that it matches. So this one, if you see, it goes 3, negative 2, so we need to do negative 2, 3, and then everything after that is just cut off. And now we can see that it is reflecting over that line. So maybe I can white it out. Shouldn't have drawn it so permanently. Do I have white out? No, I don't have white out. Okay, so, right, this part of the graph just doesn't exist anymore because we need it to match. So a good way to think about that is the domain and the range. So if we look at this pink graph originally, right, our domain is going to be 3 onward. So it's going to be 3 to infinity. And our range is going to be negative 2 to negative infinity, right? So it goes negative 2 and then it goes down forever, right? So we need to switch them for our domain and range for our inverse function. So our domain here is going to be negative 2, negative infinity, and then 3 to infinity. So we have -2 to -infinity. So we'd actually write that as -infinity to -2. And then our range is going to be 3 going up forever. So even though the inverse function was like a whole parabola, we can only take the part of it that would match, right? So if we did this over the line, if we folded it, it would have to match.
That's like, that's like when it's something with like inverse.
Pretty much you want to make sure you're checking the domain and range so that you are graphing it right.
It's like also like the inverse of the original function, correct?
Right. Well, let's see if we can take a look at a graph and maybe that'll help conceptualize it. X minus 3. Make sure the -2 is outside the parabola. Oh, maybe I should try and make it match my colors that I've been doing. And then green is -1/2. Let's do -1/2 x plus 2 squared plus 3. Okay, this zoom is weird. Standard. Okay, this shows it. This coloring is not ideal. Okay. Okay, here we go a little bit. Oh, there we go. Right, so we can see this is the original function, this is the inverse function, but we have to put domain and range restrictions on, really a domain restriction on the green to let us know that we need to cut it off like right there so that it matches. Nice, yeah. All right, let's take a look at this part right here. Zoom out a bit. Okay, so to find if something has an inverse, we have to do something, this should be a vocab word, called the horizontal line test, right? So you're familiar with the vertical line test. So pretty much, if you do a horizontal line and it crosses at 2 points, then it doesn't have an inverse. So let's change the graphs. Not that much room. So we have x and y. So we're going to switch. So 5, -2, 7, 0, -5, 2, 7, 5. So if you look here, the 7 goes to 2 different values. So this is also a no. Right? When you have a function, each x can only go to 1 y. Right? So this one also isn't a function because of these two guys. Okay, so a one-to-one function passes the vertical line test and the horizontal line test. Right? So in order for something to have an inverse without restricting the domain, it needs to be always increasing or always decreasing. All right, so let's take a look, like one-to-one mapping, right? If I had a domain and a range, and it was 2, -3, 147, 2.1, right? I could only have each one go exactly to 1 point, right? So this is one-to-one mapping, right? Each x only goes to each y. Like once, right? Alright, so for a graph, that means it's either always increasing or always decreasing. We can't even have constant because as soon as we have constant, right, it won't pass the horizontal line test. Always. Right? So if it's a one-to-one function, it's either always increasing or always decreasing. Alright. Now we got to prove that two functions are inverses. Okay, so are these two functions inverses? So So the way to be able to tell that is we need f of g of x to equal x, and we need g of f of x to equal x. All right, so let's start with this one. So we're going to plug in, every time we see x, we're going to plug in this whole thing. So we have 2 minus x minus 3 plus 3, right? So, right, that's this guy. Okay, so this cancels out. So we have 2 over 2 over x. Let's multiply by x over x. So we get 2x over 2. And then that cancels out to just x. And then here we have 2 over, and then we're going to put this guy, 2 over x plus 3 minus 3. So what can we do here? Let's times, or let's write, this is dividing fractions. So 2 over 1 divided by 2 over x plus 3 is the same thing as 2 over 1 times x plus 3 over 2. So that cancels. So we're just left with x plus 3 minus 3. That cancels. We're left with just x. So we're, right? So we know that they're inverses. So we can say, yes, they're inverses. Because when we plug each one into the other one, it gives us x. All right, those are a little tricky, but I have faith in you. All right, finally, bring the pain. Find the inverse of this. So let's switch our x's and y's. We have x equals 2y minus 3 over, and then we have another one, y plus 4. All right, so first we'll want to multiply both sides by y plus 4 to get it out of that denominator. So we get x y plus 4 equals 2y minus 3. We're going to distribute this x because we're going to have to separate this term, right? So we get xy plus 4 equals 2y minus 3. We're going to move all the y's to one side. So minus 2y minus 2y. We get xy minus 2y plus 4 equals negative 3. And then minus 4. Get rid of the 4. So you have xy minus 2y equals negative 3 minus 4 is, oh, this is minus, whoops, 4x. So negative 3 minus 4x. Okay, now we're going to pull out the y, so we're like going to anti-distribute. X minus 2 equals negative 3 minus 4x. And then finally we're going to divide both sides by x minus 2. So we get y equals negative 3 minus 4x over x minus 2. And that's our inverse. So make sure that you're doing the practice problems and checking the answers, because the inverses are pretty tricky. But it's really just solving for y, right? Solving for a variable.